Hello, everybody. Welcome back to the ocean. I'm Chum. This is Theory Chum. That's the whiteboard, and oh no, this is a flashlight. Be warned, today there's going to be some strobing lights and other effects, so anybody with photosensitivities should probably take caution when watching the episode. I will be setting up the experiment so you'll know whenever it's going to happen. So, we're here today to talk about one of the things in FNAF that gets the worst rep for barely any reason at all. We're here to talk about the 0-point field. The 0-point field in FNAF has been mentioned in the book Fetch, where we're told by Mr. Jacoby and Greg different things about it, right? Such as it's a field full of subatomic particles moving around and colliding with each other, such as people like Clive Baxter who researched it. We're going to take it a step further to truly understand what the 0-point field is. And this is a remake of an older video, so if you've seen that one, you're probably going to know some of the information today, but there are going to be different things in this video. To start, we go back nearly 100 years to 1928. Physicist P. Amdarock formulates a new hypothesis that the vacuum we exist in is a sea of negatively charged electrons. This hypothesis leads to Dirac creating what is famously known as the Dirac equation and the theory of the Dirac sea. By doing this, he was trying to provide a model that can explain why particle annihilation could explain why things could create substance, enabling the well-known law of conservation of energy to not be broken, yet something is still created. The law that mass and energy cannot be created or destroyed, only converted, such as E equals mc squared, energy equals mass times the speed of light squared. This belief also predicted the existence of antimatter 4 years before being discovered in 1932 by Carl T. Anderson. This work started the framework for quantum field theory. In traditional physics, objects are described by discrete particles with exact locations and velocities, right? So like this microphone has particles that move in a specific route at a specific speed at all times, and it's what gives it substance. It's what makes it hard. Quantum field theory updated the view that sees everything as to be these interlacing and interconnected fields, right? So you could think of how like this mic piece is attached to the microphone. It's connected to the mic. That'd be like a field connecting to another field. That's what it is. You have the mic that's existed of all of its particles, like quarks, which make up solid matter, touching another field made up of quarks. So you can think of like space-time as a body of water that's made up of multiple rivers, lakes, and oceans that all connect to each other, kind of like how the mic piece connects to the mic. In quantum field theory, there's all kinds of fields. There's fermion fields with electrons, there's boson fields with photons, even the mysterious and well-known Higgs fields. QFT is one of the most verified theories in quantum mechanics, providing and predicting particle acceleration and collision years before its time and helping us understand events like the Big Bang. And one of those fields is what we're here to talk about today. But before we talk about it, it's important that we understand some funky things about temperature. Absolute zero is 0 Kelvin. It is the theoretically coldest temperature anything can ever reach. Nothing can reach lower than that because temperature is the measurement and vibration of like atoms inside of a source. So whenever they move, the faster they move, the more there are, the more something heats up. Whenever they slow down, something's cooling off. At absolute zero, it's believed that they don't move at all anymore. They're just stopped. Except for one incident. Let's get uncertain about this, all right? Before breaking down the 0-point field, we have another stop on this ocean adventure, and that's the famously known Heisenberg uncertainty principle. This principle states that it's impossible to measure the speed and position of a particle, like an electron or photon, at the same time with perfect accuracy, because all particles act as both a wave and a solid particle, the wave-particle duality of physics. We're going to look a little bit more into that today with the experiment with the flashlight, which I've already lost. How did I already lose the flashlight again? Chat, am I doomed? Anyways, Found it. Okay. We're gonna learn more about wave-particle duality in the experiment today. Let's bring in a different example, Will. You can look at a car and see it travel, and you can see how fast it's moving, where it's at, in the same exact moment. You don't have to stop the car to tell where it's moving. Wow. Particles, however, exist in waves. But when you isolate one particle, it's no longer in that wave. You've effectively destroyed the wave by actively isolating a particle. With that being said, when energy is in its lowest form, it's impossible to tell if that energy does not exist anymore. Because the more we lock in on one particle, the less we can determine about any other particles in that wave because it's no longer a part of that wave anymore. This little quantum quirk dictates that the principle retains any tiny amount of 0-point energy even at absolute 0 degrees. So even under the belief that absolute 0 has no movement, we have to, due to the uncertainty principle, we have to understand that there is going to be movement because the particles can still be separated from waves. What is the 0-point field? The 0-point field is a quantum field, and it's at the very lowest level of energy possible, at the temperature absolute 0, where there's believed to be no movement of the energy to be detected. However, there still must be some due to Heisenberg's uncertainty principles. These fields are essentially empty pockets. Think of them like jugs of water, right? So we're going to do one of our experiments real quick. We have this lovely jug of water. With this jug of water, as you can see, it's about halfway filled up. It's pretty clear, right? This would be the 0-point field, right? You got nothing in there. It's just clear nothing, right? But then you take a particle, or a number of particles, and you add it to that field. You then change the 0-point field into a different type of field, depending on the particle you put in. Say that we just put in some nice purple electrons. This would now be a fermion field. It would be a matter field. It would create quarks because of the electron. And that is how the 0-point field works. It's really just a medium for the energy. So everything up until this point has been physics, actual physics from the real world, theoretical physics. And now we're going to apply that to Five Nights at Freddy's with another experiment and the whiteboard. For the record, this is going to be the setup. So if you're sensitive to flashing lights, you may want to look away. You could probably skip ahead in the video. I'll probably leave a timestamp of where you can resume to watch the video as well. I'll figure out how to do that. It will be somewhere around here. With that being said, today we have a 0-point field. It's just going to be, boom, that little pocket of energy, right? So we're going to hold that right. We're going to hold that right there. My masterful art skills, right? And there's nothing in there, right? It's just like little empty pockets. But there's other fields inside of it, like matter fields. For instance, human beings. We are inside of the field. Yay, the field. While we're in the field, everything's okay. And then we get the really terrible news that T.D. Reeds dropped candy bar theory in 2025. Straight fumbled it, right? So from this moment, we start feeling our emotional energy come up. starts coming out and starts filling the field. Alright? So we have our emotional energy, and it contains a bunch of tiny particles. These particles are going to fill up that field, and then boom. That field has now changed. That's because the field is the medium, right? Again, that is how agony is made. Agony is the emotional energy. It's not the field creating it. We need to be blaming the person feeling the emotions that create those results. The field is just some water in a jug. And we actually get confirmation from this from Jacoby. And this is the same basic science that is being referred to in Fetch. He says, running a hand through his unruly red hair, Mr. Jacoby began. In quantum physics, there is something known as the zero-point field. This field is scientific proof that there is no such thing as a vacuum, no such thing as nothingness. The Heisenberg uncertainty principle. If you empty all space of matter and energy, you still find, in subatomic terms, a bunch of activity. Again, the uncertainty principle. The constant activity is a field of energy that is always in motion, subatomic matter constantly interacting with other subatomic matter. So, this is exactly what I'm trying to explain to you today. They speak more, and he asks if they understand, and he continues on. So this energy is called the zero-point field because fluctuation in the fields are still found in temperatures of absolute zero. Remember, we talked about before, even if there's no molecular movement believed, they're still finding particles in energy. Absolute zero is the lowest possible energy state where everything's been removed and there should be nothing remaining to make any motion. So, with all that said, thank you for joining me. It is super hot. As you can see, I'm dying in sweat right now. I hope I was able to teach you guys a little bit of something about how it worked with our little ZPF over here. Thank you guys for joining me. If you liked the button, hit that like button. If you really liked it, swim that finger on over to the subscribe button. I'm doing my best to release content as I can. And then always remember, please leave a comment and let me know what you think. Let me know if you've learned anything. Let me know if you enjoyed the video or if you disagree. Please share my work, and until next time, keep floating in the ocean.